Welcome. This video is going to go over the solutions to the paper 1 and paper 2 questions you had on your chapter 7 CD mini quiz over Le Chatelier's principle and then some of the industry implications of equilibrium. So question number 1 says, the equation for a reaction using the manufacture of nitric acid is as follows, and you notice they give delta H as a negative 900 kilojoules. So what you're supposed to be able to infer from that is that heat is really like a product because it's an exothermic reaction. So heat helps the reverse reaction create reactant. But as far as creating product, you're trying to release heat. So increasing heat is not going to help your situation since you're trying to release it. Or if it's easier, think about it being a product. So which changes occur when temperature of the reaction is increased? Well, they're asking about both value of Kc and position of equilibrium. So temperature actually is going to affect both. It's the only stress that affects both the position of equilibrium and the value of Kc. So position of equilibrium, if you increase temperature, that's like adding a product, so you would expect it to drive it to the left. And in terms of collisions, that's because more temperature creates more collisions on the product side. It's going to create more collisions on both sides, but especially we'll see an increase on the product side. So that means your position shifts to the left, meaning it's going to be either A or B. And then the value of Kc is going to be influenced because now the product is going to decrease. We didn't add any new product to it. You know, we're thinking of heat as a product, but heat isn't actually matter. So the amount of product particles is going to decrease, the amount of reactive particles is going to increase, and that's going to lead to a decrease in Kc. And I'm actually going to make this on the quiz 2 marks because if you had either half right, that you knew it shifted to the left or you knew it was going to decrease the value of Kc, I would give you a mark toward this. So a slight adjustment on the key. Number 2, which changes cause an increase in the equilibrium yield of SO3 in this reaction? Again, heat it's exothermic, so heat can be considered a product. So I would want to decrease the temperature or remove heat. So 2 is going to be in there. As far as pressure, I have 3 moles on the reactant side and only 2 on the product side. So pressure is going to cause a greater increase in collisions on the reactant side. So increasing pressure would also increase my yield of SO3. And then adding oxygen. Oxygen is a reactant, so that would definitely help my increase of yield. So D, all 3 of these would be true. And again, I'm going to make this a 2-mark question because if you recognized at least 2 of these as increasing it, at least you knew 2 of the 3. But in this case, all 3 are going to increase your yield. Number 3, sulfur dioxide and oxygen react to form sulfur trioxide according to the equilibrium. How is the amount of SO2 and the value of the equilibrium constant affected by an increase in pressure? And they, as most of you figured out, they actually mean SO3 here because that's what they use in each of the responses. So equilibrium constant, Kc, affected by an increase in pressure. What you have to remember is Kc doesn't change. The only thing that changes Kc is temperature. So you very quickly narrow this down to D being your only possible choice because that's the only one where they said Kc would stay the same. As far as pressure, I'm going from 3 moles to 2 moles, and you might not have noticed I was being nice. This is the same equation we had up here. So we already knew that increasing pressure was going to show a greater increase in collisions on the reactant side, which means your product is going to increase, or in other words, your amount of SO3 will increase, just like we had deduced on the previous one. So again, D is my only possible. Number 4, which changes will shift the position of the equilibrium to the right in the following reaction? Adding a catalyst, that never affects equilibrium. That's only going to affect your rate. Decreasing the oxygen concentration, so that would be removing a product. That would help shift it to the right. Increasing the volume of the container. Well, since 3 moles is the more crowded side to 2 moles, what you have to remember is increasing the volume of the container would be the same as decreasing the pressure. And if you do that, you're going to see a greater decrease in collisions on the more crowded side, which is the product side. So both 2 and 3 would cause an increase in product or a shift in the equilibrium to the right. Number 5, consider the following equilibrium reaction in a closed container. You notice this one's also exothermic. Most reactions are exothermic. So don't be surprised that you'll see a lot of situations where the equation you're looking at is exothermic. Which statement is correct? Decreasing the temperature will increase the amount of SO2Cl2. This is product. And since it's exothermic, changing heat would be like changing a product. So decreasing temperature would be like removing a product, removing heat. So that's true. That would increase my amount of product. Increasing the volume of the container will increase the amount of SO2Cl2. This is a similar situation to the one above because I've got 2 moles of reactant and just 1 mole of product. But in this case, I've got the more crowded side on the reactant side, so increasing the volume is going to decrease the pressure, but it's going to shift the equilibrium to the left, not to the right. So this is false in this case. Increasing the temperature will increase the amount of SO2Cl2. Well, if decreasing the temperature increased the amount of product, then this can't be, because this is like adding the product. So if you look at A and C, they can't both be true. And adding a catalyst D, remember, a catalyst never affects the equilibrium. It simply affects the rate. So A would be my correct choice here. Number 6, which of the following equilibria would not be affected by pressure changes at a constant temperature? And what I've done is I've noted how many moles are on the reactant and product side. And you notice A, C, and D have different amounts on the reactant and product side. 5 and 4, 2 and 1, 1 and 2. The only one that's not affected is B because it's got equal volume on each side. So the crowding is going to have the same effect. Changing pressure will increase and decrease the collisions, but it's going to increase and decrease them equally on both sides. Number 7, what will happen if CO2 is allowed to escape from the following reaction mixture at equilibrium? As I've indicated here, this would be like removing a reactant, and when you remove a reactant, then you're going to form more reactant and decrease your product. And that's important here because H plus is on our product side, and H plus is what pH is based off of. So if H plus is decreasing, that actually means an increase in pH. Just a quick reminder that pH 7 is in the middle when your H and your OH are equal. And as you move to the left and you have more H plus, that number goes down to 0,1. And as you move to the right and you have more OH minus, that number moves up. So a decrease in H plus is going to mean an increase in pH. And then number 8, consider the following reaction where colorless bromide ions react with colorless hydrogen to form red-brown. So the left side has no color, the right side is the side where we see the red. So predict and explain the effect on the position of equilibrium when a small amount of sodium bromide solution is added. And with both 1 and 2 here, it's like, where's the sodium going? Well, it's not about the sodium, it's the fact that sodium bromide is a salt, so I've got Na positive and Br minus, and the question is, can either one of these ions affect my equilibrium? And bromine definitely can affect my equilibrium because I'm adding reactant and I am going to shift my equilibrium to the right as more bromine particles collide on the left side. Number 2, a small amount of sodium hydroxide. Now in this case, I've got Na plus and OH minus. And in this case, it's the OH that's going to have an effect. It's going to combine with the H plus. Okay, so with the OH minus and the H plus, it's going to have a second effect of producing H2O. So I'm not only removing H plus, but I'm making or adding H2O. So I'm definitely going to be shifting it to the left here. And you could have argued, well, what about the Na combined with the Br? Well, as long as it's aqueous, they're actually going to remain separate. But if they did combine, you're right, that would also remove reactant. And then 3, a catalyst. Now remember, this is 2 marks here, so they expect a reason. So just no change got you 1 mark, but to get the second mark, you had to mention that a catalyst doesn't affect equilibrium because it affects the forward and reverse reactions equally. Okay, so it has an effect, but it's the same effect on both the forward and reverse reaction, which means that equilibrium remains the same. And to finish up, Part B says, state and explain the effect on the value of the equilibrium constant when the temperature of the reaction is increased. Well, for this specific equation, it was given as a negative enthalpy, so we know it's exothermic. So increasing heat will be like adding product, or it will favor the product collisions versus the reactant collisions, and we will see the equilibrium constant decrease as more reactant is formed and product is consumed. And letter C, state and explain the color change when hydrochloric acid is added to the reaction. If you look back at the reaction, remember H plus was a reactant, so if I add more H plus, that is going to drive my equilibrium to the right, more product is going to form, and that would change the color to a darker red-brown.